Discuss the fine structure of hydrogen atom. So the Hamiltonian for hydrogen atom is H is equal to minus h cut square divided by 2m del square minus e square divided by 4 pi epsilon naught and 1 over 4. This is a Coulombic potential between the proton and electrons. Okay. The first correction is that for the motion of the proton and its mass is replaced by the reduced mass. Okay, and the reduced mass is equal to the mass of electron and the mass of proton divided by the mass of electron plus the mass of proton, which is approximately equal to this is and the mass of electron, which is approximately equal to the mass of electron. Today both are cancelled, is approximately equal to 1, so we can say this is approximately equal to the mass of the electron. And another important correction is the fine structure constant. Fine structure constant. Okay, so which is alpha e square divided by 4 pi epsilon naught h cut into c. And when we put the value of all these constants, then the x value is equal to 137.036. Okay. Now the fine structure constants is consist of the two terms. The first term is the relativistic corrections. Relativistic correction, and the second one is the spin orbit correction. Okay. The fine structure constant is a teeny contribution. They are very small, and the sum of the relevant energy scale is Bohr energy. The first one is the Bohr energy, which is the order of alpha square and mc square, and second one is the fine structure, which is the order of alpha 4 and mc square. Okay. The third one is the lamp shift, which is the alpha 5 order and mc square, and is associated with the quantization of the electric field, and this is smaller than the fine structure and the Bohr energy. Okay. The fourth one is the hyperfine splitting. Okay, and this is the order of m divided by the mass of proton into alpha 4 and mc square, which is smaller than the lamp shift and the fine structures, and which is due to the magnetic interaction between the dipole moment of electrons and the protons. Okay. Now we discuss the relativistic correction. Okay, first we discuss the relativistic correction, which is the term of uh, the fine structure constant. This is a relativistic correction. Now the first term in the Hamiltonian, this Hamiltonian is equal to minus h cut square divided by 2m and del square minus a square divided by 4 pi epsilon naught and 1 over r. This first term is the kinetic energy, and usually the kinetic energy is equal to 1 over 2m raised square, which is equal to an internal momentum is p square divided by 2m. And then when we plot the value of p, which is approximately equal to h cut divided by iota and to del. Okay, and then minus h cut square divided by 2m and to del square. This is the kinetic energy and the Hamiltonian. Okay, now the relativistic kinetic energy, the relativistic kinetic energy is T is equal to m square c square 1 minus v square divided by c square minus mc square, where the mc square is the rest energy. Okay, now we fix this kinetic energy in terms of momentum, then the relativistic momentum is equal to P is equal to mv divided by 1 minus v square divided by c square and under root. Okay, now we squaring both sides, then p square is equal to m square v square divided by 1 minus v square divided by c square, and now we multiply both sides c square, then p square c square is equal to m square v square divided by 1 minus v square c square, and here also c square. Okay, now we added both sides to this equation, p square c square, and then we added m square and c4. Okay, to the both sides, m square v square c square divided by 1 minus v square and c square plus m square and c4. Okay, now we can simplify this as m square v square c square plus m square c square into 1 minus v square divided by c square whole divided by 1 minus v square divided by c square. Okay, now m square c square and v square plus m square c square, we multiply this term to the 1, and then so this is 4, not 2. Okay, and this is 4. Then minus m square v square c square, the c square is cancelled to c4, and whole divided by 1 minus v square and c square, and then this two terms you can cancel. 1 minus v square divided by c square. Now we can write this. This term is cancelled to this term. Then m square c4 divided by 1 minus v square and c square, which is equal to p square c square plus the m square and c4. Okay, now we know the kinetic energy is equal to kinetic energy is equal to m square and 1 minus v square c square under root the total relativistic energy minus the rest energy. Okay, then the t plus mc square, we transfer mc square to the left side, and then mc square 1 minus v square divided by c square under root. Okay, now v square in both sides, then squaring, and m square c4 1 minus v square divided by c square. We put the value of this into these equations, then the v square c square plus the m square c4 is equal to t plus m mc square and the whole square. Okay, now we can underroot both sides, and we write this equation to this side. This is equal to t plus mc square, then p square c square plus the m square c4 and the root. We take the both sides and the root, and we have this term on the left side and this right hand side. Okay, now the t is equal to p square c square plus the m square c square and the root and minus mc square. Okay, then the t is equal to, we take common the mc square, and then p square c square divided by m square and c4 plus, this is 4, this is not good. Okay, and plus 1 and the root minus 1. Okay, this is an under root plus 1, and this is all we make. Okay, now here we use the binomial theorem. Then t is equal to m and c square. Then on this term only we use the binomial theorem. Then first 1 and then 1 over half t divided by mc whole square minus 1 over 8 and 3 divided by m or 4 and so on, and then minus 4. Okay, plus minus 1, and the minus 1 is cancelled to the plus 1. Then you can write this equation, and then the t is equal to mc square and 1 over half t divided by mc whole square and minus 1 over 8 t divided by mc whole 4 and so on. Okay, then we multiply this mc square to this two term, then this is equal to p square, the m is cancelled to the m and the c square is cancelled to the c, and only the one n is the name and q. Okay, minus 1 over 8, 1 over 8, and then when you multiply into this, and then m cube and c square and p4. Okay, and this is the result. P square divided by 2m minus p4 and m cube and c square. In the next video, we will the lowest order relativistic correction we will find. Okay.